All right. As a man of his words, I'm back. I'm back. As promised that I will continue. Question 8.5.3 on a new video. It is because now this concept it is very important. They like to assess these questions like this on an exam, and you normally find them hard. Which yeah, I am not judging, but I feel like in a way they are not that difficult. What you need to do it is to understand the concept, and this is why I'm doing these videos here on YouTube so that I can share the knowledge and how to approach this kind of questions. All right, enough about essay. This is not history. All right, 8.5.3 says now f prime x multiplied by f prime x, which is the first derivative multiplied by the second derivative, it is should be less or equal to 0. So it means now we want to multiply this function, multiply by this function, it should give us a value that is less or equal to 0. Now there are two conditions for this to happen. Remember, for something to be negative, it's either I multiply a negative by a positive or I multiply a positive by a negative. So it means I want where this one is positive and negative, or where this one is negative or positive. But before we go there, we need to draw these functions, okay? We need to thoroughly draw this function. Remember here they give us x and y, but what's important for this part it is the x coordinates. All right, remember I said to you, when you derive a cubic function, the x coordinate of the turning points become your x-intercepts of your parabola. Your x coordinate of the turning point become your x-intercept of your you realize that I'm talking about only the x, right? Okay, this is what happens basically. They become your what? Your x-intercept of the parabola. Then what? The point of inflection, which is this point here, which we calculated to be, I'll use negative 1 point, I'll use negative 1.33. You can also use the negative 1.35 depending on the method that you use. The answer is not the same, but it is very close. So here, I said this point of inflection is going to be your x coordinate of your turning point. Let me do this. It's going to be the x coordinate of your turning point. Somewhere below, I don't know where, but we'll just end here. Okay? Let's just end here there. And say this point here, it is negative 1.33. We know, right? And this one we know it is all right. Now let's try to squeeze in our function smoothly as we possibly can. Oops. I know it is skewed, but please just bear with me. Remember, it is not perfect. What's important is so that you can use these graphs. Remember, you're not required to draw this, but for the purpose of explanation and for the purpose of you answering your question in your question paper, you need this. All right. Then here it is. We have negative 3.4 here. Then we have 0.7. Sorry for the small handwriting. Let me try to zoom that so that you can see. This is negative 3.4. Okay, it's fine. Either way, we know it comes from here. Ah, all right. Now, how do I draw my straight line? My straight line is going to be drawn from Hajuang. I'm going to say, I think this one I'm going to use for other purpose. Let me see. All right. I'm going to say now, my turning point, I'm no longer talking about the F. I'm now talking about the F prime. Okay. I'm now talking about the F prime. This color is almost the same. So now, when I derive my f prime, which is my parabola, I only take the turning point. The x coordinate of the turning point is going to be every time when you differentiate or take the derivative of the turning point, it becomes the x-intercept of something. So Mara, in this case, the x-coordinate of the turning point is going to be the x-intercept of what this time? Of our straight line. So it means our straight line will have a x-intercept there. And its gradient is going to be positive. Why? Because these functions, all of them are positive. And if that's the case, it's going to be something more or less like this. You know, if you do not capitalize from me explaining this, I don't know actually what are you planning on, because now I'm here to make you pass. Okay, now that I've drawn f prime and f prime prime, I'm in a position of answering the question. Now, what do I mean where I want it is positive or negative, negative or positive? When it is positive, I refer to this as above, or let's say positive y values. When I say negative here, I refer to negative y values. All right, let's start with the first condition, positive and negative. The first condition, it is positive and negative. This one, this line here, this line. Let's start with that line there. Actually, okay. Let's start with this one. Positive and negative. Now, let's highlight where f prime is positive or above. F prime, it is positive on this portion, all right, as well as this portion. Okay, I'm slow. I am very slow, and kaboom, purposely so. I want you to understand this. Where is a? Where is our f prime prime negative? Negative, it is below. So it is between, from here, from this point to here. It is below. But we want where both of them are below and above simultaneously. What do I mean simultaneous? At the same, look here. From this portion, this there is no supporting, it is positive and it's positive. So it means now this value I do not want. So what do I do? I do this. I take where's my mouse? I'm gonna need my mouse for this one. I'm gonna say my mouse is not working. Yeah, wanna hear. So I want you to show this, then the mouse decide to do into the day, okay. Yo. Oh, let me just open my Bluetooth there. My Bluetooth. All right. Yes. Okay. Now I want you to see from this. Sorry. From this point, I'm gonna do this to 0 degrees, 90 degrees rather, so that you can see. I want you to check from this portion to the right of this, from this point to the right here. From this point, let me just use a highlighter, a new highlighter. Let's check from this point here. Yo, it's too much. From this point there, okay? Can you see that from this point going to the right, only f prime prime is negative, and there's no other green color supporting it, okay? All right. Now let's look at the left of it. At the left of it. Do you see at the left of it? We see what we want. This is positive, this is negative, simultaneously at the same time. All right. So what does this mean? It tells me that I'm gonna take where from x, from this value going to that side until infinite, negative infinite, from whatever this coordinate is here. Actually, not that one. From here, basically, from here, ish, why am I making mistakes? From here, here, actually, yes, from here, from this point now, I want you to see something. From that point there, can you see that both this graph, it is above, and at the same time this one, it is below? Okay, can you support that? Yes. So it means I want this portion from -3.4 to going to that side up to negative infinity. All right, so how am I going to write this? I'm going to say I want my x to be less than, pointing in that direction, less than what? Less than -3.4, but should also be equal. Why? Because now my thing says what? Equal here. Okay, and it is not an asymptote. Then I'm done. I want to put my ruler here for a little bit. I'm going to need it. Then I say, let me try to erase this with the hope that it won't erase my graph. Okay. Now, I'm done with this part. Actually, I'm done with this. I move on to being negative and positive. I'm done with this. Okay. Why is my f prime negative? My f prime is negative where? F prime. It is negative here. Can you see that? It is negative here. But where is my second derivative? My straight line positive. It's positive from this point going there. Okay? Yes. So now I want where they are both and simultaneously negative and positive respectively. So I want you to check from this point here. Can you see that? Okay, and this point here. I want you to check between those points. Can you see that from here? Actually, basically, from this line, going to the left, going in that direction, only we have only one color. Okay, that satisfies the condition. So it means we do not want this region. Okay, and when you check between this line and this line here, can you see that we have both this graph here, we have both this part here, as well as both this part here. So it is where both of them are segmenting, or are negative and positive respectively. So between which coordinate? This coordinate here. Now I'm going to say between -1.33 and 0.7 for now, and 0.7. It is where I want my f prime to be positive and my f prime prime to be positive and my f prime to be negative. Now let's check from this point towards the right of it. Can you see that only this function we get, and f prime, it is also positive. So it means this side we do not want also. So what does that mean? So it means now the only answers that we want, it is here. Where is my mouse? This one. This one, where it is between -1.33 as well as 0.7. So it means now these are our answers. These are our answers for 3 marks. Yo. For 3 marks. So yes, for 3 marks, this is our answer. So I believe you are following, and yes, please, if you did not understand this 8.5.3, please make sure that you rewind this video again and try to make sense of it, because now why, or actually I should include this point here. I should include this point here, equal, equal. Or someone can say it is between negative 1.33. Again, we do not use the same thing. Or here can say, remember negative infinity never include. So please watch this video again and again and again, because one thing I know for sure, in June they're gonna assess you this, especially if you are writing, they're gonna assess you this. And if you are not rewriting and you are currently doing metric, in December this question is waiting for you. Or maybe your province will make sure, especially Free State likes this type of question. But yes, that's all for question 8.5.3. Let's meet on question 9.